So good afternoon, everyone. The talk today, is about inks and processes for high conductive printed circuit. Excuse me. Don't go away.
Yeah, PDF instead of it.
Oh. Okay. Okay, thank you. So the agenda for today, I'm going to start by introducing the printed electronics Loctite portfolio, give a quick overview of the printing processes, and then present you the high conductive silver for large area antenna, and 3D printed pieces. Finally, we will cover the water-based carbon inks for energy storage and for smart healthcare. So our Loctite brand can be divided in 3 categories. So the conductive inks, that includes silver, silver chloride, carbon, copper, anything that is the main conductive part of the circuit. It's compatible with different type of substrates. It's meant for membrane switches, keypads, for different sensor type, antennas, etc. We have the resistive inks. So this one is a blend between conductive and non-conductive particle, mainly to adjust the resistivity level. It's for printed resistor, potentiometer, and heating elements. And finally, the dielectric inks. So this is the non-conductive part. It's meant to be used as the electrical insulation and environmental protection layer for different applications. So you have the dielectric layers, you have the conductive and the encapsulant. So don't worry, I'm not going through every ink right now. There's a lot. This slide is just to show you that we have many different type of inks, many different type also of inks for printed processes and applications. So if you have a problem, we probably have the solution for you. And this is absolutely not our entire portfolio. We have much more inks than that. So we usually categorize in 4 pillars our inks technology. So smart conductivity, energy, smart healthcare, and smart surfaces. Today, we're just going to talk about smart connectivity, energy, and smart healthcare. So smart surfaces, just to let you know, it's mostly printed heaters and any type of sensors we can. So the vast majority of our portfolio is meant for screen print, flatbed, and rotary, although we have also many that fits flexography and rotogravure. We also have screen printable ink that can be used for flexography as long as you have the right dilution and the right solvent. Screen print is still the main use because it's much more versatile than the other printing processes. You can print anywhere between 5 micron and 25 micron, depending on the technology. But flexo and rotogravure, it's a much more faster printing process. We also have ink that works with 3D printed. This type of printing is mainly aided by the printing head. So spray coating, jet dispensing, or aerosol jet. And finally, we have a set of inks for pad printing, which is a really technology, and I will tell a little bit later, talking about the 3 surfaces application. So let's start by the high conductive silver ink for large area antennas. So in few words, why we use high conductive ink and silver for a large antenna, it's to print less to get more. So you get a higher power, higher current density, overall higher efficiency. Because you print a very thin conductive layer, you can improve your skin effect, and overall you print less materials. It's more sustainable, and it's also very cost efficient. So our team at Henkel made a calculation, and they found out that the ink solution can save almost 50% of the cost when you compare with SPC solution. And very important, it's for a large area antenna application. I'm not talking about NFC or RFID. Okay, so this year we are launching 3 new inks, 1017, ECI 1017, ECI 1018. Thank you. ECI 4005 as our very new high conductive silver. I also included the ECI 1010 and ECI 1011 for comparison purposes with the other inks. So the ECI 1017 has a resistivity of 2.5 milliohm per square per mil. The key features of this ink is the fact that you can print, because of the viscosity, you can print a very thick layer in just one pass. So at the end, you get the lowest track